Hello everyone, this is Dharmendra Reddy M S from Department of CSCAI and Sri Venkateswara College of Engineering. Introduction to routing protocols. Routing protocols are the cornerstone of network design and operation, serving as the essential mechanisms that govern the exchange of information between different routers within a network. These protocols enables routers to select the most efficient path for data packets to travel from their source to their destination. The criteria for path selection can vary widely, involving metrics such as path length, speed, reliability, or even administrative policies. Over the years, several types of routing protocols have been developed to meet the grooming demands of complex, scalable, and diverse networks. It's crucial for network administrators to understand each type's distinct characteristics to make informed decisions tailored to their specific network requirements. Distance vector routing protocols. Basic mechanism. Distance vector routing protocols operate on a relatively simple concept. Each router transmits its routing table to its immediate neighbors, sharing the distance or vector to various network destinations. Routers continuously exchange this information to update their tables with the most favorable paths. Bellman-Ford algorithm. Central to most distance vector protocols in the Bellman-Ford algorithm, the algorithm calculates the best path to each network segment by adding the cost of each hop. Cost is often measured in terms of hop count but can involve other metrics as well. Periodic updates. Such protocols rely on periodic updates, which can lead to a slower coverage of time. It takes for all routers to agree on path selection, the characterizations and drawback in a rapidly changing network topography as it can temporarily obsolete routes. Link state protocols. State of links. Link state protocols take a more dynamic and holistic approach by accounting for the state of the network's links. Each router independently maps the network and calculates the shortest path to every destination via a well-known algorithms like event-driven updates. Updates are sent out not periodically but in response to events such as when a link changes state. This leads to quicker congruence, allowing networks to rapidly adapt to topology changes without waiting for interval-based updates. Resource intensity. Greater resource usage is a trade-off for more up-to-date routing information. These protocols need more memory and processing power, which may inform their development in larger, more complex networks that can benefit from the efficiency. Hybrid routing protocols. Combination of strategies. Hybrid routing protocols aim to capitalize on the strength of both advanced vector and state link protocols. They adapt their behavior based on network size and complexity, attempting or achieve an optimized balance between resource consumption and routing speed. Zone routing protocol (ZRP). ZRP, for example, creates zones within which it operates a link state protocol but communicates with other zones using distance vector protocols. This approach lowers the amount of routing information that must be processed overall. Quick adaptation. The result is a protocol that can quickly adapt to a vary network, and while limiting the amount of data each router must handle, protected a middle guard that suits a wide array of network architecture. Interior gateway protocols. Local area. IGPs are designed to operate within an autonomous system, which is a collection of IP networks typically under the control of a single organization. The scope is local as compared to protocols that route between SS. Examples: protocols such as RIP, OSPF, and intermediate system to intermediate system are common IGPs used within an as to ensure that internal routing is efficient and reliable. Administration centric. One key advantage of IGPs is that an organization has complete overall control over the protocol's configuration and turning, allowing for optimized performance tailored to their specific network architecture and traffic patterns. Exterior Gateway Protocol. Inter as routing. EGPs are designed to route data between multiple autonomous systems, effectively managing the flow of internet traffic across distinct BGP domains. The most widely recognized EGP and BGP, which is the backbone of the internet. BGP manages paths between SSS and ensure connectivity even amid the internet's constantly changing topology. Policy-based routing. Rather than focusing on metric like fast or shortest path, EGPs often use policies set by network administrators. These policies dictate how traffic is routed based on factors like cost agreements and business relationships. Routing Information Protocol (RIP). Hope count limit will be 15. Convergence is slow. Update mechanism is periodic broadcast. Usage is small networks. Algorithms are Bellman-4 algorithm. RIP is one of the oldest running protocols and operates on the principle of hope count as a metric considering the path with the fewest hopes to be optimal. Despite its simplicity, which makes it easy to implement and understand, RIP is not well suited for modern large scale networks due to its slow coverage and maximum hope limit of 15, which restricts network size. It uses a periodic update mechanism, traditionally broadcasting its entire routing table every 30 seconds, which can lead to excessive traffic. Open Shortest Path OSPF Link State Protocol. OSPF is a robust link state routing protocol that is widely used in a large enterprise networks. Area partitioning. It supports hierarchical routing through area partitioning, which reduces routing overhead and improves scalability by containing advertisements within areas. Cost metric. OSPF uses cost as its primary metric, which is determined by the link's bandwidth. The higher the bandwidth of a link, the lower the cost of enabling high-speed link to be preferred for routing traffic. Border Gateway Protocol (BGP). There are 700K plus routes and 4 versions. The number of unique routes managed by BGP on the Internet demonstrating its massive scale and capability to handle the global routing table. BGP has evolved through several versions with BGP4 being the current standard used to exchange routing and reachability information on the Internet. BGP is the protocol that defines how different autonomous systems on the Internet share routing information. It's unique among routing applications because of its use of path attributes, providing a robust and enhanced way to control the path that data takes through the network, based on variety of factors beyond simply the best or shortest path. Choosing the right protocol for your network. There are three types of networks: network size, performance, and policy control. The scale of your network will largely dictate your choice of routing protocol. Performance considerations including convergence, time, resource utilization, and protocols overhead should influence the choice. If you require detailed control over the route data takes, perhaps for legal, security, or economic reasons, a protocol like BGP that allows for the complex routing policies could be the ideal choice.